The distance of closest approach, the distance of closest approach, that is, if this is the alpha particle, if it is moving with some kinetic energy k and it is moving towards a nucleus head on. Okay, so this alpha particle is moving towards a nucleus head on. Now if it moves towards the nucleus head on, we have seen that there is a 180-degree deviation. Okay, so what they are asking you now is find the minimum separation. Find the minimum separation between the alpha particle and the nucleus. Suppose it's starting from a very long distance, so you will say that it starts from infinity. Suppose it starts from infinity. We need to find the minimum separation between the alpha particle and the nucleus. After this, at this point, the velocity will become 0, and after this, the alpha particle will deviate, okay, by 180 degree, right? So now, by conservation of mechanical energy, so now this nucleus is heavy, so we will assume this to be at rest, okay? This nucleus is at rest. So even though there is repulsive forces between these two, this does not affect that much repulsion because of its inertia, that is mass, okay? So that is why what you will say is this is assumed to be at rest, all right? So now if you apply the conservation of mechanical energy, you will say that initial kinetic energy is k plus the initial potential energy is 0 because they are at very large distance, is equal to finally the kinetic energy is 0, and finally the potential energy is k q1 q2 by r. Now, k is 1 by 4 pi epsilon naught, q1 is 2e, that is the charge on the alpha particle is 2e, multiplied by the charge on this nucleus is Ze, where Z is the atomic number of the nucleus, divided by R. So from this you will get R is equal to ZE square divided by 2 pi epsilon naught K. Okay, so this is the value of the minimum separation, or you can say this is the distance of closest approach. This is the minimum distance between the alpha particle and the nucleus. Now the second thing that we will find is the impact parameter. Now what is impact parameter? Suppose some alpha particle is moving parallel to this line at some distance b, then you will say that the impact parameter is b. So the impact parameter is defined as the distance between the actual line of motion and the common normal. Okay, so this is the impact parameter. Now in this situation we have seen that the particle reverses its path, but when the particle is moving with some impact parameter, in that case at every point it is experiencing repulsive force, and at every point if it is experiencing repulsive force, so it will move away from the nucleus, okay? And at one point, at this point the separation between them will become minimum, okay? So this will be the minimum separation, and this we can calculate using the angular momentum conservation that we have already studied in electrostatics. So this is just like two charges, right? We have studied in electrostatics how to find the minimum separation between them. Now here, suppose at this point the angle that it has made with the initial direction of motion is theta, okay? Then this theta is the scattering angle or the deviation angle. Now we need to find the relation between this impact parameter and the deviation or the scattering angle. All right, now the derivation of this impact parameter is not in our syllabus, so we'll not derive it, but we will only use the formula because this formula may be asked in JEE Mains, NEET as well as JEE Advanced. Okay, so now the impact parameter, which is represented by B, is equal to ZE square divided by 4 pi epsilon naught K, where K is the kinetic energy of this alpha particle, and we will again assume that this nucleus is fixed because it is very heavy, so the force of this alpha particle cannot move the nucleus very significantly. So compared to alpha particle, this is very heavy. Okay, so you will write B is equal to Z square by 4 pi epsilon naught K cot square theta by 2. Okay, now we'll check whether this formula is correct or not, right? How we will check? We know that when the impact parameter is 0, the deviation has to be 180 degree. Just put theta is equal to 180 degree, you will see that cot 90 will be 0. That means the impact parameter is 0. This term is, from here, this term is R min, right? Okay, so R min is represented by R, so I will write here this term can be written as R by 2. So they can sometimes ask you the relation between the impact parameter, the distance of closest approach during head-on collision, and the scattering angle. So you will say B is equal to R by 2, this is R by 2 cot square theta by 2. So from this you will get B by R is equal to cot square theta by 2, or the ratio of the impact parameter with the distance of closest approach on head-on collision or during head-on collision is cot square theta by 2 divided by 2. Now the third thing that you should know in Rutherford's theory is what is the number of alpha particles deflecting at a particular angle. The derivation of this is also not in the syllabus, so I will just write the relation because relation is required. So the number of alpha particle deflecting at a particular angle or scattering at a particular angle, that is n theta. N as a function of theta is directly proportional to z square divided by sine power 4 theta by 2. So from this you will say that the number of particles deflecting at a particular angle is directly proportional to z square. Now z is the atomic number, so more the atomic number, more is the particle deflecting at a particular angle. This is the atomic number, and this is inversely proportional to sine power 4 theta by 2. That means as theta increases, n decreases. Obviously you know that most of the particles are going undeviated, so n is more when theta is less, right? So if you want to draw the n versus theta graph, the n versus theta graph will be something like this, which shows that as theta increases, n decreases. So for theta is equal to 180, n is approximately very small, that is almost 0. Okay, so this is the n versus theta graph. We can do a very small question here which is very common, and that is number of particles deflecting at 60 degree per second is, suppose, n. Then find number of particles deflecting at 90 degree per second in the same experiment. Now if the experiment is same, that means z is same. Now if z is same, that means the number of particles, n is inversely proportional to sine power 4 theta by 2. So from this I will write n1 by n2 is equal to sine power 4 theta 2 by 2 divided by sine power 4 theta 1 by 2. So from this you will get n1 by n2 is equal to sine power 4. Now initially the number of particles deflecting at 60 degree. So initial angle is 60 degree and final angle is 90 degree, right? And initially the number of particles deflecting is n. So I will write here n by n2 is equal to sine power 4 90 by 2 divided by sine power 4 60 by 2. So from this you will get sine 45 is 1 by root 2. 1 by root 2 power 4 is 1 by 4. And here sine 30 is half, and half power 4 is 1 by 60. So from this you will get this is equal to 4. So that means from this you will get n2 is equal to n by 4. So that means if n number of particles are deviating at an angle 60 degree, n by 4 particles are deviating at 90 degree. Okay, this relation, the exact relation of number of particles versus theta is not in the syllabus. We are only writing the proportionality. This is not the exact formula, and we are not deriving this formula. This is not required for us in the JEE mains and advanced syllabus, okay, and not also in the NEET syllabus. All right, so with this we have completed Rutherford's experiment.